All right, welcome. Today, we're going to pull back the curtain on the VMware cluster. We're going to see how you go from just a single server to building a computing environment that isn't just powerful, but, well, it's also resilient and incredibly smart. So let's just dive right in.
But first, let me just start with a question. Imagine this. What if your servers could just never fail? I mean, what if the physical machine running your most important app could survive a power outage, a hardware meltdown, pretty much anything you throw at it? I know, it sounds a little bit like science fiction, right? Well, this is the exact problem that VMware clusters were built to solve.
So to understand how we get to that almost magical place, we have to start small. We've got to start with the most basic piece of the puzzle in any data center, the single host. This is our foundation, our one and only building block for now. You know, an ESXi host at its heart is really just a powerful computer. It's got all the things you'd expect. A CPU, which you can think of as the brain, memory, which is kind of like its short-term thoughts, storage, that's its long-term memory, and of course, the network, which acts as its voice and ears to talk to the rest of the world. But, and this is a really big but, here's the crucial point. When you're running everything on this one machine, you're taking on a massive risk. Because if that one host goes down for any reason, could be hardware failure, a power blip, anything, everything on it goes down too. Your online store, closed for business. Your database, totally offline. It is the definition of a single point of failure. So, how do we solve this scary single point of failure problem? Well, it turns out there's power in numbers. It's all about teamwork. And this brings us right to the core idea of this whole explainer, the cluster. So what is a cluster, really? Think of it like a team of all those individual server hosts. They all get together and agree to pool their resources, all their CPU power, all their memory, into one big pile. So instead of having a bunch of separate, isolated computers, they start acting like one giant, powerful, and way more resilient supercomputer. And this idea of a shared pool of resources, that is the absolute key. It is the secret sauce. It's the foundation that makes all the incredible, almost magical features we're about to talk about even possible. Okay, let's get into the first piece of that magic, and this is so cool. It's the ability to move a running computer, a virtual machine, from one physical server to another without anyone or anything even noticing it happened. It's a technology called live migration. Now, there are basically two flavors of this live move. First, there's vMotion. Think of this as moving the computer's brain and its active thoughts, the CPU and memory, from one physical box to another. The whole goal here is zero downtime for whatever application is running. Then you've got storage vMotion. This is more like moving the bookshelf, all the machine's data files, from one storage system to another. And again, this all happens while it's still running. It's perfect for when you need to do maintenance or upgrade your storage without any interruption. Okay, so now let's see how all these pieces come together to create something truly amazing, the self-managing data center. See, once you have a cluster, you suddenly unlock these automated superpowers that just handle all the hard stuff, like resilience and efficiency, all by themselves. And superpower number one is called high availability, or HA for short. The best way to think about HA is as the cluster's automatic safety net. It's always there, always watching, just waiting to spring into action if anything goes wrong. So how does this safety net actually work? Honestly, it's brilliantly simple. So step one, a physical server in the cluster suddenly fails. Maybe it loses power. Instantly, high availability sees what happened. And step two, it automatically restarts all the virtual machines that were on that failed server on the other healthy hosts in the cluster. And just like that, step three, your services are back online. There's a little blip, sure, but it's minimal disruption. For any business, this is the difference between a tiny hiccup and a full-blown crisis. All right, on to superpower number two, the Distributed Resource Scheduler, or DRS. Now, if HA is the safety net, think of DRS as the super smart traffic cop for your cluster. It is constantly watching how much CPU and memory every single machine is using. And if one server starts getting overworked, DRS just automatically uses that vMotion magic we talked about to move some VMs over to a less busy server. It's automated load balancing, and it makes sure everything is always running as smoothly as possible. But what if that minimal downtime we get from high availability still isn't good enough? What if you have an application that needs zero downtime, like none, ever? Well, for that, you need the ultimate level of protection. And this is where the distinction is so important. High availability, HA recovers from failure. It restarts a machine after a host dies, which gives you minimal downtime. But fault tolerance, or FT, it does something else entirely. It prevents anyone from ever even knowing a failure happened. It works by keeping a live, perfectly mirrored, identical copy of your virtual machine running on a totally separate host. If the main one fails, the shadow copy takes over instantly, seamlessly. The result? Absolutely zero downtime. This is for those systems, think financial trading, emergency services, that simply cannot fail, not even for a millisecond. So look at where we've ended up. We've gone from a single, fragile server to this intelligent, self-managing, self-healing cluster. And that journey really brings us to one final, powerful question. When our infrastructure becomes this smart, when it can handle its own failures and balance its own workloads automatically, what bigger, more important, more interesting problems are we now free to go out and solve next? Now that's something to think about. Thanks for tuning in.